This week we're beginning our 3D unit. Before we start finding surface area and volume of these different 3D figures that we're going to be talking about, we first need to be able to identify 3D shapes. So before we do that, we're going to just kind of review our two-dimensional shapes that we're familiar with. Remember, perimeter is the amount of space or distance around the 2D figure. Labels are to the first power, meaning my label is inches or centimeters or feet, etc. We don't have the exponent of 2. It's just plain old feet or inches. Whereas the area, its label is to the second power, meaning inches squared, centimeters squared, etc. In the table, you'll see the shapes that we're most familiar with. These are our 2D shapes. They're not three-dimensional. They're just basic two-dimensional shapes. We're going to complete the table by labeling how many sides, vertices, and edges each of these 2D figures have. I'm going to do the first few with you and then give you a few minutes to try to complete the rest of the table on your own. The first figure we have is a triangle. A triangle has 3 sides. Vertices, those are like your corners. How many points does your triangle have? 3. Edges. For two-dimensional figures, your number of sides and number of edges will be the exact same. So 3 edges as well. Let's try the pentagon. A pentagon has 5 sides. It also has 5 vertices, my 5 corners. And again, it also has 5 edges. Take a few minutes and see if you can complete the rest of this table. I think after a few, you'll be able to see a pattern. Also, for this unit, these are the shapes that you need to be familiar with. You need to know that a pentagon is a 5-sided figure. You need to know that a hexagon is a 6-sided figure. So make sure that you're familiar with these names and able to identify what shape it is based upon how many sides that it has. All right, so take a few minutes and see if you can complete this table on your own. I'm sure that you quickly saw the pattern that for every shape, every two-dimensional shape that is, its number of sides, edges, and vertices are all the same. So you are finding the same value in each row. Pentagon has 5, 5, 5. Hexagon has 6 sides, 6 vertices, 6 edges. Heptagon has 7 sides, 7 vertices, 7 edges, and so on. So that was just a little quick review over the two-dimensional shapes. Now we're going to talk about three-dimensional shapes. Three-dimensional figures with straight surfaces are called polyhedrons. So prisms and pyramids are examples of polyhedrons. If you look further down the page, it lists three-dimensional figures with curved surfaces. Those are not polyhedrons. So examples of our non-polyhedrons, because they don't have straight surfaces, would be our cylinders, our cones, and our spheres, because they're curved. So back to our polyhedrons, our prisms and our pyramids. Prisms have 2 parallel and congruent bases. So prisms' 2 bases will be exactly congruent. The sides of prisms are always rectangular. So a prism has rectangular sides. Its sides are made up of rectangles. Whereas pyramids, they only have one base. The sides of pyramids are always triangular. So all of the sides of a pyramid are always triangles. We name 3D figures in two ways. We name it by its base shape, and we name it by the number of bases. So if it has two bases, we know it's a prism. If it has one base, we know it's a pyramid. So we determine whether it's a prism or a pyramid, and we are more specific by naming it by its base shape. For example, triangular pyramid or square pyramid. So we are very specific with prism and pyramid by naming them by their base shape. And then again, three-dimensional figures with curved surfaces are not polyhedrons. Examples of those would be cylinders, cones, and spheres. Next table that you see, we're going to look at some different prisms and pyramids and identify their base shapes, how many bases they have, how many vertices they have, how many lateral faces and edges they have. So like we just said, we know that prisms will always have two bases. So I'm going to go ahead and fill that out now. I know that every single prism is going to have two bases. And I know that every single pyramid only has one base. All right, the first one, rectangular prism. Even if I did not have a picture of this prism, remember we name them by their base shape. Well, its name is a rectangular prism, which means its base shape has to be a rectangle. Next, we have a triangular prism. It's named after its base shape, so its base shape must be a triangle. Pentagonal prism, and you can see in the picture, its base shape is a pentagon. Let's go ahead and finish the rest of our prisms out, and then we'll go down to our pyramids. Rectangular prism, how many vertices does it have? How many corners? So if you think about your box, you would have 4 corners up top on your top base, and then you would have 4 corners down below on your bottom base. So my total vertices on a rectangular prism would be 8. Lateral faces. Now I want you to make a note to yourself in this column for lateral faces that when we talk about faces, we do not include the base or bases. So I do not calculate the bases when I'm counting how many faces there are. So forgetting about my prism's bases, top and bottom, how many sides, how many faces would this prism have? Good, 4. And then the last column, how many edges would this prism have? So let's go back to think about our top and our bottom. I have 4 edges around the top, I have 4 edges around the bottom, and then I have 4 sides that make up my height. So altogether for edges, that makes a total of 12. Triangular prism, number of vertices. How many corners does my triangular prism have? I have 3 corners on my top triangle and 3 corners on my bottom triangle, so 6. Number of lateral faces. Remember, we are not including the bases, so I do not count my 2 triangular bases. I only want to count how many rectangular sides are around this prism, which is 3. And last of all, number of edges. How many edges would this triangle have? Take a second and see if you can think about that. The correct answer is 9. I have 3 edges up top, 3 edges on my bottom triangle, and the 3 edges that make up the actual height of the prism. So 9 total edges. A pentagonal prism, 10 vertices, 10 corners up top, 10 corners down on, 5 on the top and 5 on the bottom on each of my pentagonal bases. Number of lateral faces, again, do not count the bases. I do not count the pentagons. How many rectangular sides do I have? 5. 1 coming down from each side of the pentagon. 1 rectangle coming down from each piece. And then last of all, number of edges, 5 up top, 5 edges on bottom, and then 5 that make up the height, so 15 total edges. Now that you're kind of getting the hang of this, see if you can try completing the 2 pyramids on your own. For the pyramid, I have a rectangular pyramid, so its base shape is a rectangle. It only has 1 base. Like we said, all pyramids only have 1 base. We have 5 vertices. We have 4 on my bottom rectangle, and then that 1 point at the very top. 4 lateral faces, 4 triangular faces that are coming up from each of the rectangle pieces on the base. 8 edges. 4 around, and then 4 that come up to make my height. Triangular pyramid, triangle base, 1 base. Every pyramid has 1 base. 4 vertices. I have 1 on each of the corners of the triangle plus the 1 up top gives me 4 total. 3 lateral faces. I have 3 triangles coming up from each of my pieces. And then edges would be 6. All right, the next page, a net. A net is a 2-dimensional figure that can be used to build a 3-dimensional figure. So right now, I'm looking at the net. It's just 2-dimensional pieces, triangles and rectangles. But if I wanted to, I could cut this net out, fold it up, tape it, glue it, whatever, and I could make this a 3D figure. So that's what we're trying to think about. What would this net form if I were to cut it out and make it an actual 3D figure? So let's start out actually by just identifying the bases and faces. That will, I think, help us determine what kind of shape it is. I have rectangles and I have 2 triangles. If I have a lot of rectangles, that probably means that I have a prism, because prisms have rectangular faces. So these rectangles would be my faces, and these 2 triangles would make up my 2 bases of my prism. So my base shape are the triangles. And I know it's a prism because it has 2 bases. And remember, we name the prism by its base shape. So a triangular prism. How many bases? 2. Every prism has 2 bases. Lateral faces, 3. I have 3 rectangular faces here. Number of edges. Don't let the net confuse you. Sometimes thinking of a net or looking at a net can confuse you when you're trying to think of how many edges there are. So if I were to construct this triangular prism, how many edges would it have? Good, 9. 9, making 3 from each of the triangular pieces, 3 around each base, and then the 3 that come up to make the height. So giving me a total of 9. How many vertices? 3. If I were to construct this, I would have 3 corners on my top triangular base, 3 corners on my bottom triangular base. So again, this can be kind of confusing if you're looking at the net. So try, if you can, to visualize the actual 3D figure and to be able to identify its different attributes. Name a figure and base shape. What do you guys think that this figure would be if I were to cut this out and fold it up and make it an actual 3D figure? Good, a cylinder. It cannot be a cone because a cone only has one circular base. So this is a cylinder, and it has a circular base. Its base shape is a circle. How many of those circular bases? 2. Lateral faces. Lateral meaning straight. No, 0. There are no straight faces. If I were to make this cylinder, fold it up, tape it, make it an actual 3D figure, it would be a curved surface. Remember, a cylinder is a non-polyhedron. It does not have a curved face. So we would want to put 0. Yes, it looks like a rectangle when we fold it out and make its net, but remember, you have to envision the actual 3D figure. How many edges? 0 again. If I were to make this actual cylinder, it has no straight edges. Everything is a curved surface. Everything is circular. Again, vertices, 0. This cylinder does not have any points. Everything is curved. And you don't have to put your slashes through. You can just write them normal zeros if you want. Number 3. What do you think this shape would be? It looks to me like they're all squares, which would make it a cube. But then again, we don't necessarily know that they're all 4 congruent sides, making it a square. So I would call this probably either a cube or a rectangular prism. But just to be safe, because we don't know that they're congruent, let's go ahead and call it a rectangle base. And base, if I were to fold it up, so these other 4 pieces would be my faces. Rectangular faces, 2 bases, makes this a prism. It's very important to be able to identify the difference between prisms and pyramids. And because my base shape is a rectangle, this would be a rectangular prism. Number of bases, 2. Again, every prism has 2 bases. Number of lateral faces, face, 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 face. So I have 4 lateral faces. Number of edges. Think about your actual prism. If I fold this up, make it an actual 3D prism, I can pick up and touch all of its pieces. How many edges would this have? 4 up top around my top rectangle, 4 on bottom around my bottom rectangle, and then my 4 edges coming up to make the height of the prism, making there a total of 12 edges. Last piece, number of vertices, 8. If I had this, think of a box. If I had a box, how many corners would it have? 4 corners up top and 4 corners down bottom. Last one, number 4. Base shape, circle. Because I only have 1 circular base, what do you think the name of this 3D figure is? Good, a cone. If I were to cut this object out and fold it up, it would form to be a cone. How many lateral faces? None. Again, if I were to make this its actual cone, it would be a curved surface. So it's a non-polyhedron, making no lateral faces. How many edges? 0. Again, if I were to make this actual 3D figure, everything would be curved, no straight edges. unlike a cylinder, a cone does have one vertice. It has that one point at the very top whenever you form its 3D figure.